In this example problem, a child kicks a ball initially at 10 meters per second at 25 degrees above the horizontal. The child is standing 7 meters away from a house. At what height above the ground does the ball strike the house? So let's dissect this. We have a child kicking a ball. So the ball is going to come up here and it's going to hit the house at some point. And we know from the problem that the child is standing 7 meters away from the house. So we have 7 meters here. This is going to be delta x because it's a horizontal distance. We also know the initial velocity, and we know the angle above the horizontal, so 25 degrees. And remember, just because it hits the house, we exit the problem just before it hits the house, so the velocity final is not 0. So if you run through your list of equations in the y direction, because our goal here is to find the height, or the delta y value here. If you run through your list of equations in the delta y direction, they all either require time or the final velocity. So let's turn to our x direction equations. We have an equation for delta x that equals the initial velocity times the cosine of theta times t. And remember, time is not a vector. Remember, we're not allowed to time travel in this course. So that means that the time it takes for the object to end up over here in the x direction is the same as it is to end up above the ground, or the delta y quantity. Because the ball is actually going like this, it's not going like this and going like this. So the time it takes to fly through the air is the same for both the x and the y. This means that we have this value, we can find this value, which we then can plug into one of our y direction equations to find the height. And you can see this is what I did up here. I used that relationship. I plugged in my 7 meters for the delta x, my 10 meters per second for the initial velocity, and then theta was 25 degrees, and I solved for time. And I got 0.77 seconds. I then used the relationship that the change in the y direction is equal to the initial velocity times the sine of theta times time plus 1/2 times the acceleration times time squared. So I'm going to plug in 10 meters per second times the sine of 25 times our 0.77 seconds plus 1/2 times the negative 9.8 meters per second squared, because that's acceleration in the y direction, times 0.77 seconds squared. And that's going to give me 0.35 meters. So remember, time is a link between the x and the y direction because the object follows a parabolic path. It doesn't go in the x and then go in the y. It follows a parabolic path, changing xy coordinate as it goes across.